For the web server example that we talked about on the previous slide, note that all the processes, all these cooperating processes, they share the same code and same data. So they have the same address space. They are the clones of the same original process. They all share the same privileges. They share the same resources in the server. For example, the files, the sockets, network sockets, and so forth. So if this is, let's say, the clone 1 and this is clone 2 of the web server, we have seen that they are both the clones of the same original web server process. So they have the same code. So what is different here? So the difference is actually in the execution state. So it is possible, let's say, that this clone 1 is serving client 1 request and clone 2 is serving client 2 request. Maybe client 1 requested a sound file, and let's say client 2 was requesting a video file. Therefore, this web server clone 1 would be executing logic for serving the sound files, and this web server clone 2 would be executing code for serving the video file. So their execution states, or the program logic that they are executing, that is different. So which is actually represented by the value of their program counter, a stack pointer, and the state of their register files. These would be different because they are running different program logics within the same code. Perhaps they are executing different functions within the same program. Going back here, out of these 4 bullets, the first 3 properties of the process, the code, the privileges, and the resources, these are the same across all the child processes. But the last one, the 4th bullet here, the execution state, this is different. And therefore, if we are somehow able to separate the concept of a process from its execution state, we may be able to save the overhead of creating a new copy of the process every time there is a new client request. And this is the key idea behind threads. So threads essentially separate the concept of a process from its execution state. Process here represents the address space, the privileges, and resources that are needed for executing the process. And the execution state refers to the state of the program counter, the stack pointer, the register files. The execution state is also called a thread of control or simply thread.